the sun burps on a regular basis. It's called a coronal mass ejection, and it's like a burp when a big blob of stuff, highly charged sun stuff, plasma particles, gets launched at extreme velocities, like 1,000 times faster than our rockets fly. And most of the time it flies out into space in directions away from the Earth, and it's no big deal. Well, every now and then it comes towards the Earth, and we had a pretty severe geomagnetic storm a few weeks ago, made incredible northern lights over the northern and southern hemispheres, as you get close to the poles. But on the scale of things, it was bigger than most people have seen in a long time, but it was fairly small historically. Back in 1921, we had the Great Geomagnetic Storm of 21, where it lit up the skies incredible in the northern and southern hemisphere, in the north all the way as far south as Haiti and Hawaii, and from the south as far north as Samoa. So all but the deep tropical zones of the world were affected electromagnetically and geomagnetically. Now, in those days, there was no power grid, there was no internet, there was no nuclear power plant, so it was just kind of no big deal. It burned down a few telegraph stations. Penn Central Station burned down from induced power surges in the lines, but not that big of a deal. Life went on, The world was used to getting by without electricity and internet. Well, fast forward to today, if a storm of that intensity, or an even bigger one that happened in 1859, just 60 years earlier, so 90 years ago we had an extreme event, 60 years before that an even bigger extreme event. If either of those events happened today, they would fry these giant power transformers that our grid is 100% dependent upon, that didn't even get invented until around 1970. So these huge transformers, it turns out from scientific modeling, are extremely vulnerable to geomagnetic storms along the magnitude of what happened then. In fact, we had one in 1989, roughly 1/10 as strong as a 21 storm, and it fried 3 of these giant transformers, 2 in North America and 1 in the UK. And it caused some problems. 9 million people lost power for 6 hours, but it was only 3 of these in the world that got cooked in that storm, 3 of these giant transformers. And if it happened today, you're talking 350 in the United States alone, 2,000 plus in the world, and they only make about 100, 150 of these a year worldwide manufacturing capacity. So you're talking one single geomagnetic event wiping out what we've taken the last 30 years to build and taking the grid down catastrophically over most of the industrialized world. Now, as you mentioned, how does this involve nuclear power plants? Well, nuclear power plants require constant cooling to keep their cores from melting down. When you shut down a power plant, it's not like flipping a switch in the wall. You have to keep those cores cooled for 3 to 5 years after you turn the switch off. And so what happened in Fukushima, according to Japanese authorities, was not that the earthquake directly caused the meltdown and the failure of the reactors. It failed the grid immediately. The reactors went into backup mode, where battery banks and backup generators kicked in to keep the pumps working, to keep the water flowing, to keep the cooling happening, that keeps the cores from melting down. Well, 20 minutes later, the tsunami came along, wiped out those pumps, wiped out those backup generators and backup battery packs. Cores stopped cooling. A couple hours later, catastrophic meltdown, starts dissociating the water into hydrogen and oxygen from the extreme temperatures. Hydrogen and oxygen, when they're in gas form, they become explosive. They caused explosions, breached the containment vessel, and we had a giant catastrophe on our hands. Now, we're talking, in this long-term grid down situation, potentially 400 Fukushimas or Chernobyls all over the world going off at nearly the same time. Basically, as soon as those backup generators either A, run out of gas, or B, fail due to a geomagnetic, electromagnetic effect directly, then as soon as those failures happen from either lack of fuel or electronic failures, then you start having power plants blowing their tops and all over the world. So this is a game-over serious event. Now, the good news is that they have developed technologies to protect us from not all the bad effects of an EMP, electromagnetic pulse, or a naturally occurring geomagnetic solar storm, but against the worst effects, the game over, game change, end of the world as we know it effects of collapsing the grid and the resultant blowing up, or not blowing up, but melting down and catastrophic failures of nuclear power plants, many, maybe not all, but many throughout the world, or probably the vast majority if it's a really bad event like 1921 or 1859. So you ask the question like, well, what's the chance? And, why are people not worried? Well, the chance that this will happen is 100%. I mean, these geomagnetic storms, twice in the last 160 years, that's not like something that happened 50,000 years ago and might happen today like a pole shift. This is something that happens on the average of every 75 to 100 years throughout history from looking at ice core samplings. The thing is, the last time the really big one happened was 1921, before modern microelectronics, before the internet, before nuclear power plants, before a widespread grid. So we're blissfully unaware, for the most part, of this problem. Now, why hasn't the government done something about it? Well, they've been talking about it since 2008. They've been voting on a few various bills, the most recent one called the SHIELD Act, and they so far haven't passed it. They've come close, but not quite. But the industry, you say, well, why isn't the industry doing this? Well, the industry is saying, we don't want to pay for this. We're a for-profit, and we think the government should do it. Now, the current SHIELD Act is putting the onus on industry to pay for these safeguards to be put in place. And so the industry lobbyists are out there lobbying, saying, it's no big deal, don't worry, we don't want to pay for this. So here you have people who are basically saying it ain't that bad because we don't want to pay for it. They're not saying it ain't that bad because there's real scientific evidence saying it ain't that bad. They're just saying it ain't that bad because they've got somebody to say it isn't that bad. Kind of like the global warming, climate change deniers. They pay some PhDs to say it just ain't that bad. But the tests, the studies, the national studies, sponsored by the Oak Ridge National Labs and independently checked by the Sandia National Labs on the Meditech study, the effect of geomagnetic storms in the U.S. power grid, basically says, this problem is worse than we thought. This problem is huge. We have fixes. If we don't fix them, it's going to be just like New Orleans and Hurricane Katrina, where the engineers said, we got a problem. It's not a question of if, but when. And when that big storm hits, we're going to lose a lot of New Orleans. Well, when this big geomagnetic storm hits, we're going to lose most of the world, not just New Orleans.
If this happens, we know the storms are going to happen. That's not in question by any scientist anywhere.
Correct.
It's how severe will it be? That's what's in question at this time, right?
Well, because it's a crap shot, you know the extreme severe storm will happen. You don't know if this solar maximum coming up around the end of 2012, beginning of 2013, is going to bring us that event like 1921 or 1859 Carrington event. That's a crap shot. But the scientists, I've read numerous reports where they're really worried because this solar maximum is heating up quite quickly, extremely active before the actual peak of the maximum. They're extreme concerned that we may well see an event along the lines of 1921 or 1859. Now, we just don't know if it's going to be that bad. If we're lucky, we get an in-between event that scares us silly and knocks out, like 15 of these giant transformers like happened to South Africa in 2003 in a geomagnetic storm. That's a tiny fraction of the one in 1859 or 1921.
Right, but let's say that we have not the worst case, but in somewhere in between. Do we have the backup systems in place that we could go in there, and let's say we have New York City, and we have in New York State we have several nuclear power plants, but two at Indian Point. Let's say those went down. Do we have the capacity to go in there and fix them, or any other nuclear facilities? Can we go in and fix?
We can keep them going if we have a 2003 South Africa situation. It will be chaotic in the country. It will be extremely tough running business because the only way they could keep the country running electrically is to do rolling blackouts throughout the entire country. Imagine trying to run your business when on any given day, 6 or 7 hours out of your workday you might be blacked out on power. And there's 100 million businesses out there who want to buy backup generators to keep their businesses running when the power's down. So there's absolutely no way you're going to get a generator because you're in line with 100,000, or a million other people looking for generators.
Let me give a scenario. You tell me whether or not you believe this scenario is realistic or understating or overstating the issue.
Okay.
Let's say that we have the solar storms come. Let's say they come at night. People wouldn't know it till they went to wake up in the morning and would not find that their telephone, their television, their internet, no electrical service. If they were in a building, their elevator wouldn't work. And when they go downstairs, they would find that there are no traffic lights. So needless to say, under any circumstance when traffic lights are not working, you have congestion because otherwise people have to have someone directing them of who's going to go and who's not going to go if you have all these people. You would find that your refrigerator and freezer would be out. But most people would probably think at that moment, electric's out for some reason.
Right.
And I believe that there would be anywhere from a 6 to a 12-hour period where people would simply be asking others what's happened, and because it would be too soon for the government to send in FEMA and go up and down streets saying there's been electrical failure, please stay in your homes, conserve water and food. Right. I believe it would be about 12 hours before you'd start to see the first people panicking. And then you would see people rushing to the stores to empty out flashlights, candles. It depends upon whether it's winter or summer, water and food.
Right.
I then believe, I'm not quite finished, then believe after 12 hours, more astute people, if they have a car, will try to go someplace where they feel there may be electric working or somewhere further away if they start to see that there's problems, but then those people who didn't have the full gas tank are going to say, how far can I go when I only have half a gas tank? Because there's no gas station that will be able to pump gas because it's all based upon electric. Their toilets won't work and no water out of the taps.